Hello kids. So today we are going to discuss our NEET today's question paper. The chapter for this particular today's NEET paper was first halogen derivative of alkane, second one was alcohol, phenol and ether. The third chapter was aldehyde, ketones and carboxylic acid, and there was one more chapter called as practical organic chemistry. So kids, let's discuss this questions what you have got on the screen. Now child, when you see the question what you have got, the question number 1, it says that there is an alkene given to you. They have given the reagent which is HBr, and I think so on the arrow you can see it's a peroxide. So basically whenever you have got an alkene with an HBr with a peroxide, basically it is which reaction? Yes child, it's an anti-Markovnikov rule. So basically what should be the answer? Now let's write the reaction over here child what we have. So over here I have taken a cyclic ring what you can see very clearly, which is nothing but this, having a double bond. Now you have got over here as CH2, then you have got something called as CH, then you have got something called as CH2. Now this is that alkene which is given to us. Now when you treat this with HBr, correct, as on the arrow it is given as peroxide, what should be the answer? The answer should be what? Now child, if you remember, in classroom we have discussed one shortcut, and what is that child? That whenever if you follow a Markovnikov rule, you get higher degree of compound, and whenever you carry out an anti-Markovnikov rule, you get lower degree of a compound. Now basically in our example, if you check, the double bonded carbon what you can see over here, yes, is the primary carbon and this is a secondary carbon. Now you tell me, out of these two carbon atom, which is the lower degree of carbon atom? Yes, of course, it's a primary. So in this case you will get nothing but primary halide only as the answer. But let's apply the concept with the statement, your negative part of the reagent gets attached to the carbon atom containing more number of hydrogen. So your H will get attached over here. So the answer what you will have is a cyclic ring having a benzene ring in short. Then you have got over here as CH2, then you have got CH, then you have got a double bond CH2. Now if you remember child, I have told double bond, but I have not put a single bond in that which is a pi bond, because we have to break that. Now what will happen over here? You will have got H over here and you will have Br over here. So your correct answer for this given MCQ is nothing but option C. Is it term clear child? I hope this question is clear. Let's proceed with the next question child what we have. Yeah. So here the next question what we have on the screen is, when a toluene reacts with chlorine at a low temperature in presence of catalyst FeCl3, the product obtained is what? Now basically child, let's see what is a toluene. Now child, I have written over here a benzene unit having a CH3, can I call it a toluene? Now when you treat a toluene molecule with a chlorine in presence of FeCl3, basically child, do you remember, this is nothing but a reaction of a benzene, and benzene shows which reaction? Electrophilic substitution reaction. Now my question is child, will the chlorine will be the second member to enter on the ring? Now when a second member has to enter, you should know which is the first member present on the benzene ring. I think so, it is an electron donating group, and basically whenever if you have got a donating group, the product obtained are ortho and para. That means in this reaction child, what will happen? One of the chlorination will take place on para position of a toluene molecule. Yes. And one more probability product would be that your chlorine would get attached to ortho position of the benzene, and hence the byproduct in this reaction would be your HCl. Now question comes this child, that do we get two products? Yes, in this case we get two products, but out of which one will be major, other one will be minor. Now generally which one is major? Yes, para chlorotoluene would be the major product and this would be the minor product. Now if you see properly, the question says that what is the product obtained? Yes, they have not mentioned that a major product. That means for us the correct answer key would be D, a mixture of ortho and para chlorotoluene. I hope this question is clear, child, to you. Let's see the next question, child, what we have. Now here, child, they have given when a chlorine is passed through propene at 400 degrees centigrade. Which of the following is formed? Now, child, this is one of the very common reaction. Let's take a propene. How do you write a propene, child? It's a CH2, double bond CH and CH3, correct? Now, you should know one thing, child, whenever you take a chlorine, yes, what will happen? Now, basically when you put just only a chlorine, it should undergo addition reaction, but since this reaction is carried out at 400 degrees centigrade, so instead of addition reaction, it will undergo a allylic halogenation. And what is allylic halogenation? You can see you have got this position, child, which is called as allylic carbon, and on this position you have got one H and one Cl will get lost outside as HCl, and the product obtained would be CH2 double bond CH and CH2 over here. One of your H will get replaced by Cl. And what is this compound called as? Yes, this compound is known as allyl chloride. So whenever alkene is treated with an halogen at high temperature, child, instead of addition, it will undergo a allylic substitution reaction, and hence the correct answer for this MCQ is nothing but option B. I hope this is clear, child. Let's take the next question, child, what we have on the screen. Now here, child, they have mentioned what? The reactivity order of 2 bromo 2 methyl butane, 1 bromopentane and 2 bromopentane towards SN2 displacement. Now before we start anything, let's first of all write these 3 compounds. Now the first compound they have mentioned is nothing but a butane. Yes, and to this butane I have got a bromine at the second position, and I have got one methyl group also at the second position. Yes. Now, second example, this is the first one. This is the first one. Let's take the second one. Now, the second compound is nothing but given to you as pentane, and it contains one bromine group. So, this is nothing but my compound number 2. Now, let's see the third one. The third compound I have got is nothing but a pentane, and this pentane contains a bromine at second position. Now, before we start as the example, let's try to identify which one is a primary, secondary or tertiary halide. Now, child, if you see, this is nothing but a tertiary carbon, so we call it as tertiary halide. Here, this is nothing but a primary carbon. Here, it is nothing but a secondary carbon. Now, basically, let's talk about the reaction. Now, what they have told that you have to find out the reactivity order towards SN2. Now, when you talk about basically SN2 reaction, correct? Now, SN2 reaction, basically, what is the key word for SN2, child? Yes, it's a backside attack. And when you talk about backside attack, your nucleophile will attack to the substrate which will be least bulky. So, reactivity order is what? Your primary alkyl halide is more reactive than secondary halide. Your secondary halide is more reactive than tertiary halide. So, if you see in that way, the reactivity order, yes, out of the 3 example given to us is the second one would be the most reactive. Then I think so the third would be there, which is secondary, and the least reactive in that would be the first one. So your correct answer has to be 2, 3 and 1. I think so in that case your option C exactly matches with the option. Is it clear, child? I hope so. This is also clear, child. Let's proceed with the next question then. Now, next question what you have got on screen is the reaction of benzyl chloride with sodium cyanide followed by reduction with hydrogen in presence of nickel give. Now, before we start anything, first of all, a child you should know is benzyl chloride. Now, what is benzyl chloride, child? I think so you have got a benzene unit containing one CH2 group and then one chloride. Is it clear, child? Now, treat this with sodium cyanide. Now, when you treat this with sodium cyanide or potassium cyanide, I think so the answer is what? It will undergo nucleophilic substitution and the product obtained would be nothing but cyanide only. Means your halide group will get substituted by cyanide. So, what will happen? Here you will have a benzene ring having a CH2 and having a CN group. So, this is benzyl cyanide, what is the product obtained. But now, there is another point also given, followed by reduction, means I have to carry out now reduction with H2 nickel. Now, when you do reduction, basically what happens? Obviously, your cyanide group gets converted to what? Amines as primary amine. So, your answer for this question would be, this is a benzene ring, correct? Here you have got CH2, here you have got CN. Now, just add the hydrogen over here and that is 2 over here and over here. Can I call it a primary amine? Now, question is, how will you name this? Now, basically, this compound what you can see in front of you is not an aniline, because aniline is nothing but where NH2 is directly attached to benzene. Now, this compound cannot be also called as benzylamine, because benzylamine should have one CH2 less. So, even this is not the example. Now, if you check, sir, how we should name this compound then? Yes, I will tell you. This compound can be named as, in this particular way, that can I call this is nothing but an ethylamine? Yes, it's an ethylamine. It's an ethyl amine as a common name. Now, during a common naming system, do you remember, child, we use alpha, beta, gamma as the Greek letters to indicate the position. So, here the carbon atom which is attached to a functional group is called as alpha. The next one is beta. So, can I tell that it contains a phenyl ring and at beta position it is. So, can I call it a beta phenylethanamine? And that is why the correct answer, child, what we have right now is nothing but answer A. I hope this is clear, child. So, let us proceed to the next question, child, what we have. Now, over here the next question what we have is, methyl bromide and ethyl bromide are mixed in equal proportion and the mixture is treated with sodium metal. The number of possible organic products are. Now, child, if you remember, this reaction is nothing but Wurtz reaction, where you know that whenever if I take a methyl bromide and along with that we take ethyl bromide and it has been treated with a sodium metal. Obviously, child, we know that over here there are possible 3 products which can take place. And what is this? 2 products would be a self-coupling product and 1 product would be a cross-coupling. So, let us see over here. The possibility number 1, what it can happen is your methyl group can get combined with methyl to form ethane as one of the option. Second, ethyl bromide will react with another ethyl bromide to give you butane as the answer. I think so both these products are self-coupling products. And the last one, methyl can also combine with ethyl group, child. Is it clear? And here the answer would be propane, which is nothing but a cross-coupling product. So, basically in Wurtz reaction, when you have got 2 different alkyl halides, the number of probable products would be 3, because you have to include self as well as cross-coupling products. So, where the correct answer for this MCQ is 3. Is it done, child? Let us move to the next question, child. What we have? Question number 7. Now, this is one of the very common reaction, child. The best method for conversion of an alcohol into alkyl halide is by treating alcohol with what? Now, child, one of the very common reaction what you have got is what? This is an alcohol. When you treat alcohol with SOCl2, what would be happening? Here I need to have a catalyst which is a pyridine in presence of solvent, you can say. What will happen? Obviously, the product obtained is nothing but alkyl chloride. The other products are obtained as sulfur dioxide gas and HCl gas. Now, please remember, child, since both the byproducts what you have got in this reaction are gaseous byproduct, and being a gaseous byproduct, they can be removed very easily from the reaction mixture. Yes, and no extra cost would be required for a businessman commercially. Hence, this can be a best method. Is it done? I think so. The name of this reaction, what we all child know, is a Darzin's process. So, one of the best method to prepare alkyl chloride is by SOCl2. Is it done? Correct? So, let us proceed with the next question, child. What we have? Now, child, they have given what? The compound that will undergo SN1 reaction with the fastest rate. Now, bacha, when we talk about SN1 reaction, yes, or you can say, child, it's nothing but reactivity of SN1 is nothing but what? It's nothing but directly proportional to what? Stability of carbocation. Because in SN1 mechanism, the first step is what? Your leaving group will go out and you will get a carbocation form. So, as fast or as more stable the carbocation you get, more would be the reactivity. So, let us now do one thing in this child, one thing, and what is that? I will just take this question down to just show you what happens in this case. Over here, suppose if I remove this Br out, we will get over here a carbocation. Over here also, when I remove this, I will get a carbocation formed over here. In this case also, when I remove this, I will get a carbocation in this, and in this case also, when I remove the leaving group Br, I will get a carbocation. Now, out of all these carbocations, child, if you see, in option D, it is resonance stabilized carbocation. Now, if it is resonance stabilized carbocation, it will be more stable as compared to the other one. So, the correct answer for this particular question is your D. Is the term clear? Chalo. Let's proceed with the next question, child, what we have got on the screen. Now, what is given over here? I think so, it's based on classification, child. The given compound, what is given in front of you, is an example of. Now, I think so, you know that functional group is attached to an sp3 carbon and which is next to a double bond. Can I call this situation is called as a allylic halide? And yes, the correct answer for this MCQ is nothing but it's an allylic halide. I think so, this question is clear, child. As we will move to the next question, child. Now, question number 10. Aryl halides are less reactive towards nucleophilic substitution reaction as compared to alkyl halide due to. Now, basically, when you talk about aryl halide, what is aryl halide? Let's take an example over here. As over here, I have got a pi bond in a benzene ring having over here any halogen you can take. We can take Cl also, we can take X also. Now, we are going to compare this with an alkyl halide. Let's take an alkyl halide I have considered as CH3, CH2 and Cl. Now, the question is what? Out of these two, which one is more reactive? As they are telling that aryl halides are less reactive. That means the more reactive one is nothing but this one. But now, question is why? The answer is, child, in case of aryl halide, do your chlorine contains a lone pair, and do lone pair is in conjugation with the pi bond. Hence, because of resonance, child, will it get a partial double bond character, and because of that your bond strength will increase and hence bond breaking will be difficult, and the answer is due to resonance. So, here the correct answer is nothing but due to resonance stabilization. Is the term clear? I hope this is clear, child. Let's take the next question. Now, on the screen, child, what you have got the next question is, which of the following exhibit highest boiling point? Now, basically, child, when you see Boiling point depends upon some parameters, like the first parameter is based on intermolecular forces, and I think so when you talk about intermolecular forces, correct, the one who will have hydrogen bonding, yes, would have a higher boiling point than the one which has got a dipole and the one which has got van der Waal. So, the one which has got hydrogen bonding will have got a higher boiling point, and the one with the van der Waal forces will have lower boiling point. Now, my question is what? In our example, which you can see in the option, everywhere I have got alcohol, that means all of them can show hydrogen bonding. So, this point cannot be that much great to help us. So, the second parameter is what? Boiling point is directly proportional to molecular weight or molecular mass. Now, let us see over here, if you have got over here, it is a 2 carbon atom alcohol. I think so over here it is a 5 carbon atom alcohol. Here it is again a 5 carbon atom alcohol, and again here it is 1, 2, 3, 4, 5 carbon atom alcohol. That means one thing is very clear. If they have asked which will have highest, of course your A cannot be the answer, because everywhere I have got 5 carbon atoms. Now, if you see example B, C and D are isomers are of each other. So, there is another parameter also what we do. Boiling point is inversely proportional to branching. As your branching keeps on increasing, your boiling point will decrease. So, if you see your straight chain alcohol will have got a higher boiling point as compared to branch. So, here your correct answer is B. Is the term clear? Yeah, I hope this is clear. Let us see the next question what we have on the screen, child. The compound which reacts fastest with Lucas reagent at room temperature. Now, child, when you talk about Lucas reagent, what is this reaction? Let us say, whenever if you have got an alcohol and when you treat that with HCl in presence of anhydrous ZnCl2, what will happen? Your OH, NH will get lost, and over here you will get the answer as R attached to Cl, and water would be a byproduct. Now, question is, HCl plus ZnCl2 is only known as Lucas reagent. Now, the next important part is reactivity order. Reactivity order of alcohols, yes, is tertiary alcohol more reactive than secondary alcohol. Secondary alcohol is more reactive than primary alcohol, and I think so this reaction comes under CO breaking of the bond, correct, and hence the correct answer for us should be what? Out of this we should find out which alcohol is primary, which alcohol is secondary, which alcohol is tertiary. Now, basically in the lecture I have given you one logic, child. Whenever if you have got a functional group and a position of the alkyl group same, it has to be a tertiary. So, I think so the correct answer in this case is D, if you recollect. And still if you have a doubt, just write and check. How many carbon atoms they have given? Prop, correct. On a second position I have got a functional group. So, right now this situation is secondary, but on the same position if you have got a methyl again, will this carbon atom will turn down to a tertiary, and that is why I have told that option D is my correct answer. Is the term clear? Sure. So, D is the correct answer. I hope this is clear, child. Let us move to the next question. Now, child, over here what is given? When 3,3 dimethyl 2-butanol is heated with H2SO4, the major product obtained is. Now, basically let us write first of all this part. Now, over here, child, I have got over here 4 carbon atoms. So, I have written all 4 carbon atoms, you can see clearly, child. Now, on second carbon atom I have got OH, and on the third carbon atom, child, I have got 2 methyl groups. Now, can I put all required number of hydrogens? Now, before we start anything, child, first of all you should know Whenever if it is heated with H2SO4, obviously it's a dehydration. So when you studied dehydration, if you remember child, mechanism wise, the first step is nothing but a protonation. Obviously the first step is protonation. So what will happen? The first step is protonated alcohol will be formed. So I have got CH3, I have got over here CH3, here CH3, here you have got CH, here you have got CH3, and here you have got OH2 plus, correct? Now what is the next step child? Your water molecule will be acting as a good leaving group, so it will go out and you will get nothing but over here as CH3, 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 here you have got CH, and here you have got CH3 with a positive charge. Can I call it a secondary carbocation? Correct now child? Now what you can do is child, see I have told you in the lecture also, once the carbocation is formed, just give a chance to check, do we get a more stable carbocation or not. If we get more stable, we have to go for it. And here I think so, if you see, if I carry out a methyl shift over here, let's see what do we get. So now after methyl shift, the answer would be CH3, CH3, CH and CH3, correct? What has happened? From here I have shifted one methyl group over here, correct? And you have got a plus charge over here. So have I got a tertiary carbocation, and tertiary carbocation is more stable as compared to a secondary carbocation, which is less stable. Now finally what? Now what is the last step of this mechanism child? Deprotonation. Now for that deprotonation child, what I will do is, from this position you can see your H will get eliminated child, it is a deprotonation, and what would be the product form child? CH3, CH3, here you have got CH3, here you have got CH3, so one pi bond is formed over here. So this is nothing but my product alkene formed. So here in this example you have to think about carbocation rearrangement. So the correct answer what we have is nothing but the answer as A. I hope this is clear child. Let's proceed to the next question child. Now question number 14, what it says? Phenyl magnesium bromide reacts with methanol to give. Now basically this is one of the very common reaction child. What is phenyl? Phenyl is nothing but you have got a benzene ring attached to a magnesium and then bromide. Now it has to be treated with what? It has to be treated with methyl alcohol. And what is the product obtained? Now child, if you remember or no, I don't know, but let's try to recollect. When a Grignard reagent is treated with any solvent which shows an acidic character, what happens in that case? You get an hydrocarbon as a compound form. Now how it will be? Let's see over here. Do this H is an acidic H? Yes, it's a polar protic solvent. So this becomes your delta minus part. Now we know that in Grignard reagent your magnesium is a positive part and this carbon atom is the negative part. So what happens? Here your Grignard reagent will act as and base. So it will go and attach to this H. So the answer obtained in this case would be benzene as the product form, correct? And the byproduct obtained is what? Where Mg will be attached to Br and the new part what you have got is OCH3. I think so in this case your benzene is nothing but your product. So what is the answer child? It gives you a mixture of benzene and MgOCH3 Br what is mentioned over there. I hope this reaction is clear child. Let's try to go for the next question. Now, question number 15, what is there on the screen? Which of the following are the starting material for a synthesis of a third butyl alcohol? Now, basically child, let us have one discussion. Suppose if alcohol is obtained as a product and the starting material, if you see everywhere given is Grignard reagent, correct? Then the starting material has to be either aldehyde or a ketone. First point, is this child clear? Now let us have some logic. Now what is that logic? Suppose if a formaldehyde is there, correct, and if you treat that with Grignard reagent, generally what we get is primary alcohol. Suppose any aldehyde is given to you, with a Grignard reagent to be reacted, we get a secondary alcohol. And last one, when a ketone, this is point number 1 to be noted, second, and this is the third point. When a ketone has been treated with a Grignard reagent, I think so, the product obtained is tertiary alcohol. Now let us see what is the question. Now see, the product to be obtained is third butyl alcohol. Now third butyl alcohol is nothing but a tertiary alcohol. If it is a tertiary alcohol, that means your starting material has to be ketone. So now if you see over here, you can see it's an aldehyde. So this answer key is not possible. Even this example is also not possible. So the correct answer we have got is two options, which you can see, A and C. But now in A and C, when you see, it's what? Now if you see, I have got a third butyl alcohol as a product form. Now what is third butyl alcohol? Something a third butyl alcohol is like this. Now which contains how many carbon atoms, you have to decide that. Yes, so from this you can see it contains 4 carbon. Now it has to be treated with what? Now in both the compounds I have got same compound ketone. That means I have taken CH3, COCH3, correct? Has to be treated with Grignard reagent, correct? Now we have got a product with 4 carbon atom, correct? Yes, 4 product. Now ketone is of 3 carbon atom. So which number you will add, so you will get the answer 4? Of course, that has to be C1. That means it has to be a methyl magnesium halide. That means the correct answer what we have got is option A and not the option C. Is it done? And instead of writing this also, you can check it out, bacha, over here. Ketones contains 3 carbon atom, ethyl magnesium contains 2 carbon atom. So when you do this reaction, it's an addition, you will get 5 carbon atom alcohol, which is not this one. So even this also can be another elimination technique to solve. Now I hope this is clear, child. Let's proceed to the next one. Now the next question what you have got on the screen is a major product obtained on interaction of phenol with sodium hydroxide and carbon dioxide. I think so this is one of the very simple name reaction, child. I have got over here a phenol molecule, which I think so you can see very clearly, correct? Now this is treated with what? Sodium hydroxide, correct? After that you have got something called as carbon dioxide, yeah, and along with that you will require little bit amount of H plus ion. The product obtained in this case is nothing but where you will have phenol and on ortho position you will have got nothing but a carboxylic acid. That means in this case you will get nothing but salicylic acid. Is it term clear? I think so this is one of the name reaction and the name is, it's a Kolbe's reaction. Is it term clear, child? Fine. I hope this is clear, a very simple question. Let's proceed to the next one. Now the next question what you have got over here on the screen is 0.24 moles of phenol was treated with excess of bromine in presence of water, all the phenol got quantitatively converted to bromophenol. The number of moles of bromine reacted where? Now, basically what is this reaction if you see? Now, it is a phenol. Now, phenol molecule is allowed to treat with bromine, correct, in presence of water. Now, you have got one reaction child, phenol reacts with bromine water. The product obtained is nothing but 2, 4, 6 tribromophenol. That means your bromination takes place at 3 positions called as ortho, para and ortho. That means you need to over here have 3 moles. So, can I tell that the ratio in which phenol reacts is 1:3. Is it term clear? So, if I take 1 mole of phenol, it will require 3 moles of bromine, yes, to completely brominate. Therefore, if I take 0.24 moles, it will give me how much? So, basically it is a cross multiplication 3 into 0.24 and that is the answer I think. So, what you get is 0.72 moles of bromine would be required, and I think so the correct answer what we have got is nothing but option C. So, here the important part was the reaction of bromine is to phenol in water is 1:3 in ratio. Is it done, child? Let us proceed with the next question, child. What we have now, I think so this is one of the very common reaction again. Ether is given with HBr. So, basically bacha, when we have seen in past, I think so this is nothing but what? And anisole molecule given to you, correct? Fine. Now, we know that it has to be treated with HBr. Now, already we know one shortcut, child, and what is that? Whenever if you have got an aromatic ether and when you are treating with HBr, we will always get phenol as one of the product. But let us see how we have got that. Over here, can you see that you have got lone pair? Yes. Now, this lone pair gets involved in the resonance with the pi bond of the benzene. Hence, this bond becomes a strong bond. This bond becomes a strong bond, and on the contrary, the other bond what you can see is comparatively a weak bond. So, now tell me one thing, child. If the bond has to break, I think so which bond is going to break? This one, child, where your Br will get attached over here and your H will get attached over here. So, the answer in this example would be, I have got in this case phenol and methyl bromide as the another product. So, the correct answer for this particular MCQ is nothing but option D. I hope this is clear, child. Let us proceed with the next question, child, what we have on the screen. Now, identify a Z in the sequence. Now, basically, child, what is given over here? I think so it is nothing but it is but-1ene, correct? Now, treat this with HBr, and along with that I think so they have given as peroxide. So, basically it is which reaction, child? It is an anti-Markovnikov rule. Now, basically what do you get in anti-Markovnikov rule? I think so in anti-Markovnikov rule the negative part will go to that carbon atom which contains which contains more number of hydrogen. So, H will come over here. So, you will get the answer as CH3, CH2, CH, double bond and CH2. So, I have not written a double bond, but I have told because I am going to add over here your H and here it is a Br. So, this is my first product which is something called as Y. Now, what is the second step, child? Yes, the second step is nothing but treatment with sodium ethoxide. Now when you treat this with sodium ethoxide, you should know one thing, that it's a salt, and we know that alkyl halide likes to undergo nucleophilic substitution. So here you have delta minus, here you have delta plus. So what do you see in this case? Your nucleophile attacks over here, your NABR is lost as a byproduct. So what is the product obtained? You have got CH3, then you have got CH2 group 3 times. So can I write CH2 group 3 times? Then you have got O, and then you have got ethyl group. So the correct answer, yes, for this reaction is this Z product. I think so. Out of this option, the most probable option is option C. Is the term clear? I hope this is clear to you. Let's move to the next question, child. What we have now here, child, the question given to you is what? Isopropyl benzene is oxidized in presence of air to give a compound A. When a compound A is treated with dilute mineral acid, the aromatic product is obtained. Now basically this is one of the very common reaction, child. If you remember, as per the syllabus, isopropyl benzene is nothing but known as cumene. Yes, and cumene is one of the commercial way to prepare a phenol. So cumene, when on treatment with, yes, oxidation, yes, you get some intermediate product. That intermediate product, what you have got, the name of that intermediate product is called as cumene hydroperoxide, and which on further treatment with mineral acid, yes, mineral acid, you get over here phenol and acetone as the byproduct. This is one of the commercial method to prepare a phenol. So here, as per the question, what they say, the aromatic compound what is formed in the reaction is nothing but your phenol. So your correct answer is A. I hope this is clear, child. Let's proceed with the next question. What we have now, child, over here, which one is the most acidic in nature? Now I think so there are two types of a group present in the nature. I have already told you a long back. One is called as electron withdrawing group and other one is known as electron donating group. Now the question says that, first of all, which groups are there which comes under donating and which comes under withdrawing? So all negative showing effect, minus I, minus H, minus R, they are all withdrawing effects. Plus I, plus H and plus R showing effects are donating effects. Now, which group has a tendency to increase the acidic strength? Of course, electron withdrawing group increases the acidic strength and donating group decreases the acidic strength. Now, if you check over here, in this compound, child, you have got over here 3 minus R groups. How many groups? 3 minus R groups. Here I have got only 1 minus R group, what you can see, correct? Here I don't have any additional group apart from phenol, and here I have got nothing but a methyl group, and when methyl is attached to benzene it shows plus H effect. So basically which group is the one who will increase the acidic strength? I think so, in that case your correct answer has to be C. So if you want to get an acidic strength order, we can even give the order also in this case. The first example has to be C, which is most acidic. Then you have got a B. Then you will have got that example A, and the least basic would be nothing but example D. So we have to find out the correct answer as most acidic, but I have even given you the order also. I hope this is clear, child. Let's proceed with the next question. What do you have got on the screen? Now, reaction of phenol with a chloroform in presence of a dilute sodium hydroxide finally introduce which one of the following functional group? Now, basically when you see a phenol, correct, when reacts with chloroform and NaOH, correct? I think so. This reaction what we have studied is called as Riemann-Tiemann reaction, and in this particular reaction it is also known as orthoformylation of phenol. That means the product obtained in this reaction is going to be a salicylaldehyde. Now, what is salicylaldehyde? You have got a phenol, and to an ortho position you have got an aldehyde group. So, which is that new group which is introduced in case of phenol? So, if you see over here, I will just give you over here what is a phenol unit. So, a phenol molecule is nothing but what? Benzene ring contains an OH part over here. So, which is the new group which is introduced? I think it's an aldehyde. So, the correct answer is C. I hope this is clear, child. Let's move to the next question what we have. Now, ethyl alcohol exhibit acidic character on reacting with. Now, child, remember one thing. Alcohols are very weak acidic in nature. Even litmus paper does not show any test for alcohols. So, only one reaction which can be used to indicate that alcohols are acidic, and I think so, that is what? Take ethyl alcohol, it is ethyl alcohol, treat that with sodium metal. What happens in this reaction? You can see that your H comes out. Yes, so what you get over here as C2H5O minus, and this Na will go over here as sodium salt, and you get H as given out. But we know that H cannot be stable in the atomic state. So, you need to balance this reaction, and will I get nothing but a hydrogen gas. So, here you can see that only sodium metal, only reaction with sodium metal can explain that alcohols are acidic in nature. That means your correct answer is sodium metal. Is it term clear, child? Let's proceed with the next part, child. The next question what we have is, over here one reaction is given, and let's write that reaction. I have got over here 2-bromopropane. Now, what is 2-bromopropane, child? You can see very clearly. I have got CH3, I have got CH, I have got CH3, correct? And I have got Br over here. The first step, treat this with alcoholic OH. Now, basically what alcoholic OH does, I think so, alcoholic OH does elimination. So, what will happen? This is my leaving group, and from the adjacent position I can have a loss of H. So, will I get nothing but the answer as propene. Now, what is the next step? I have got, this is compound A, which is this one. Now, this on treatment with HBr, with peroxide, I think so, it's an anti-Markovnikov rule, where your negative part will go and attack to that carbon atom which contains more number of hydrogen. So, here the answer would be CH3, CH. Here you will have CH2, here you will have CH and Br. So, this becomes your primary halide. Now, last step, this is compound B. Now, last one is treat this with sodium methoxide. So, we know that it's a plus part, it's a minus part. So, what will happen? Obviously, this nucleophile will attack this carbon and the leaving group will go out as NABR. So, the correct answer is CH3, CH2, CH2 and you will have got OCH3. So, can I call it a methoxypropane? Yes, because it's a long chain and the position of a methoxy group is also on the first carbon atom of the propane chain. So, can I call it 1-methoxypropane? And I think so 1-methoxypropane is nothing but this one, child. Is it clear, child? Let's take the next option, child, or sorry, next question, child, what we have on the screen. Now this is one of the very name reactions, straightforward. And what is that reaction, child? oxidation of a toluene to a benzaldehyde by using chromyl chloride. Now, if you see, this is one of the very common reaction, child. I think so we have got a toluene, and when you treat this with chromyl chloride in presence of non-polar solvent, that is carbon disulfide, the product obtained is known as benzaldehyde. That means this reaction is used to prepare aromatic aldehyde, and the name of this reaction is ABHYAS oxidation. So, here in this case, I think so the correct answer is B. I hope this is clear, child. Let us take the next question, child, what we have on the screen. Now, 26, ozonolysis of C7H14 gives 2-methyl-2-pentanone, 3-pentanone, the alkene is. Now, before we start anything, let us see. I have got an alkene, correct? And what is the formula for an alkene? C7H14. So, there are 7 carbon atoms. And what this on ozonolysis gives? Ozonolysis, what it gives? Chalo, let us write. It gives you, child, 2-methyl 3-pentanone. Now, before we start anything, child, just wait for a moment. Now, how many carbon atoms do we have with us? Is 7, correct? It's a 7 carbon atom situation, correct? Now, in ozonolysis, it is giving me 6 carbon atom. It is giving me 6 carbon atom. That means over here also 1 carbon atom compound is missing, correct? And that missing compound is nothing but, I think so, formaldehyde, because 1 carbon atom ketone cannot exist. So, only 1 carbon atom aldehyde exists, which is formaldehyde. So, let us now see how to get. Now, what is the logic to be remembered? How do you write a structure of this compound? Now, see, in ozonolysis, the logic is what? Write a carbonyl group. Write a carbonyl group, correct? And I have written over here as CH3, C, over here CH3. Now, it has given 2-methyl. So, can I put over here 2-methyl? Correct. So, I will put required number of H's. Now, what has to be done? The situation is like this, child. You have to remove both these oxygen and just join. So, what do you get a product in this case, child? CH3, CH, C, CH2, CH2 and double bond CH2 having 1 methyl group. So, now when you check the long chain, well, your long chain is going to be like this, which indicates there is 1 carbon atom, correct? It's 1 carbon atom, it's a second carbon atom, it's a third and it's a fourth. So, you have got 1 ene, that's very clear, I think so. There is one more logic, child, which you can even remember. Whenever if you get a formaldehyde as one of the product, that means it indicates it's a terminal double bond. That means in this example, child, if you check, I can eliminate this my option because it's a 3, it cannot be terminal. Even I can cut this example also, it cannot be a terminal. So, both these options are cut, only now left out options are 2. Now, as per the question, what you can see, on a second position I have got ethyl and on third position I have got methyl. So, second position ethyl and third position methyl. So, the correct option is A. I think so, this is clear, child. Yeah. Let us take the next question, child, what we have. Now, what is the product of the following reaction, child? Now, I think so, you understand over here it is given as lithium aluminum hydride. Now, lithium aluminum hydride is used as a reducing agent, and we know that your aldehydes and ketones on reduction, when you go towards the left hand side, it gives you alcohols. That means the product obtained would be alcohol, that is clear, fine. So, this cannot be the answer. Next, Even you should know one thing, that your lithium monohydride do not attack carbon-carbon double bond. That means your double bond should remain double bond, it should not be getting affected. That means in both these examples, if you check, double bond is not there. That means the correct answer in this case is this. So, over here you can see your ketone group has got reduced, but double bond has not got reduced, and that is nothing but the selectiveness of a lithium aluminum hydride. So, the correct answer for this question is B. Let's say the next question, child, what we have. Now, increasing order of rate of HCN addition to a compound A to D. Now, basically when you see, this is nothing but based on reactivity of aldehydes and ketones. Now, basically when you talk about aldehyde and ketone, aldehyde is more reactive than ketone because there are two factors. One is steric hindrance and second is electronic effect. Now, as you see, compound becomes more and more bulky, your reactivity decreases. Now, out of see all these examples, I think so this is containing two phenyl rings. So, this is the most bulky. I think so formaldehyde is the one which contains both H. So, this is least bulky. So, one thing is very clear, when you talk about reactivity order, and that is also in the increasing order, means low to high. So, least reactive in that case will be D. Now, who will be more reactive? I think so the most reactive is A. Now, out of these remaining two, B and C, if you check over here, there is two methyl groups. Here you have got one methyl and one phenyl. So, this is again more bulky. Yes, and this is less bulky. That means when you arrange, you will get nothing but next is C. And then next what you have got is B. So, the correct answer key for this example is nothing but I think so it's nothing but option C. Is it clear, child? Let us take the next question what we have on the screen. Now, question number 29 is a very straightforward question, and which of the following compound will give aldol condensation? Now, which are basically you should know aldol condensation is shown by compounds having alpha hydrogen. Of course, aldehyde and ketones having alpha hydrogen. Now, here if you can see, this is nothing but that functional group. This is alpha position but no alpha H, so this cannot be the case. If you take an example, it is shown by aldehyde and ketones, so phenol cannot be the case of example. Here again you can see it's nothing but a functional group. Here you don't have alpha hydrogen, so even this cannot be the case. Here you can see, bacha, there is an alpha position both the sides and you have got alpha H available. So, the correct answer which can show aldol condensation is nothing but your option C. Is it done? I hope this is simple, child. Let us proceed to the next question, child, what you have got on screen. Over here now see, they have given one reaction and the reaction says that I have got over here, it is a CH3 and a double bond O. Now, it has been treated with sodium cyanide and HCl. Now, basically with this what happens? Basically with this it happens like this, that your cyanide is the nucleophile and we know that aldehyde ketones like to undergo nucleophilic substitution. So, here you will have Cl. So, this electron pair shifts over here making it as O minus and that O minus will take that H. So, what will be happening? You will get nothing but the answer as CH3, it's O, and over here you have got something called as H connected and the nucleophile what we have got is cyanide over here. So, this compound is known as cyanohydrine and this is obtained from acetone. So, this is named as acetone cyanohydrine. Now, this is nothing but a compound A. What is the next thing? This compound on further hydrolysis. Now, when you do further hydrolysis, we know that your cyanide group can get hydrolyzed to a carboxylic acid. So, the product obtained would be CH3, CH3, here you have got OH and here you will have got carboxylic acid. So this is nothing but my compound B, which need to be the answer key. So let's check what should be the answer. Now in the final product I have got alpha hydroxy acid. So this cannot be the answer. Even this cannot be the answer because you don't have an acid group over here. Okay. Now in this case, child, you can check over here there's an acid but you don't have an hydroxy group. So even this is not the answer. So your correct answer is this. Is it term clear? So the product obtained is what we know as alpha hydroxy carboxylic acid. I hope this answer is also clear, which is MCQ number A. Oh sorry, MCQ number 30, where the correct answer is A. I hope this is clear, child. Yeah. So kids, let's proceed to the next question what we have on the screen. Now here if you see, the next MCQ is like this. We have got phenyl magnesium bromide and it has been treated with carbon dioxide, and the second step is hydrolysis. Now this is one of the very common reaction, child, of preparation of carboxylic acid. Now basically what will happen in this case, let's see. I have got over here a phenyl magnesium bromide, correct? Now treat this with carbon dioxide. Now when you have got a carbon dioxide, I think so I have written like this just for addition. So you know that this is delta minus, this is delta plus carbon. So what will happen? This is your nothing but carbon delta minus, magnesium is delta plus. So this C minus will go and attack to this carbon atom, Mg will go and attack or get attached to oxygen. So here the intermediate obtained would be of this type, where you have got benzene. Here it's a carbon dioxide where your double bonded oxygen will now become single bonded. The attachment is with this carbon, and here you have got magnesium with bromine. Now this is a magnesium complex. Now what is the last step, child? The last step is hydrolysis. Now basically which bond will break? This OMG bond will break, where a negative part O is there, so positive part of the water will come and magnesium will have the negative part of the water. So here the product and a byproduct would be of this type. You will have a benzene containing a carboxylic acid, and a byproduct would be Mg, Br with OH. Now important is what? The product is what? I think so for this MCQ, child, your correct answer is D. Is it clear, child? Let's see the next question, child, what we have on the screen. Now here the question is like this, child. We have got an alkyl benzene, which is ethyl benzene, and it has been treated with KMnO4. Now basically when you talk about KMnO4, is it nothing but an oxidizing agent? Yes. So which answer is very simple. Alkyl benzene on oxidation gives carboxylic acid irrespective of your carbon chain. That means whenever if you have got over here alkyl chain of 2 carbon atom or 1 carbon atom or maybe 4 carbon atom or maybe more number, it will get oxidized to a carboxylic acid. So in this case your correct answer is nothing but your C. Is it clear, child? Yeah. Let's proceed with the next question, child, what we have on the screen. Now here what they have given, formic acid and acetic acid differs in which of the following respect. Now basically, child, when you write an acetic acid, we write like this, it's a CH3, C double bond O and OH is an acetic acid, whereas formic acid is written as H, C double bond O and OH. Now basically just tell me one thing, child. In your acetic acid, it contains only one functional group, which is carboxylic group, correct? Whereas in formic acid, it contains one of the group which is called as carboxylic group, correct? Now apart from carboxylic group, it contains one more group also, and that group is called as an aldehyde group. That means your formic acid is an exceptional carboxylic acid which gives even a test of carboxylic acid and also of aldehyde. That means out of this 4 option, if you see this option, what you can see, reduction of Fehling solution. I think so Fehling solution test is shown by aldehydes, and hence formic acid can get this test positive or can reduce Fehling solution, whereas acetic acid won't. So the correct answer for this question should be C. So kid, I think you have understood this. Let's proceed with the next question. Now I think so here the question given to you is what? Cyclohexanone is there, and I think so this compound where you can see is called as an primary amine. Can I call this reaction as of ammonia derivative? Now what is the reaction of ammonia derivative, child? It's a very simple reaction. You have got a cyclohexanone and write your primary amine in such a way that your amine H is clearly observed, and then you have to write the remaining part of the group as CH2, what you can see. Then you have got CH, and then you have got that CH3 twice. Now we know that whenever aldehyde and ketone reacts with an ammonia derivative, there is a loss of water molecule, yes, and the product obtained in this case would be a cyclic compound having a double bond, having N, then you have got over here CH2, then a CH, and then a methyl group 2 times, and the name of the product generally they have given is Schiff's base. And remember the child, this reaction is known as condensation reaction, or we can call it as Weil mechanism. It's an nucleophilic addition followed by elimination. So I think so correct answer for this MCQ is option D. So kids, let's proceed with the next question. Okay, on the screen I think so you can see a very clear reaction, child. Identify the starting material or starting reagent which needs to make the following compound by a cross aldol. Now basically when you talk about cross aldol, what you should know in a cross aldol, the product obtained are alpha beta unsaturated aldehyde or a ketone. Now see, you can see very clearly it's a ketone and this is something alpha and beta. So it's alpha beta unsaturated aldehyde or a ketone. Now question is how to find out the starting material. Now child, if you remember, there was one logic which I have told you. Break your double bond and put a water molecule in such that your beta carbon gets an oxygen and your alpha carbon gets both the H's. So now if you check situation wise, I think so this molecule what you can see is benzaldehyde, correct? And this molecule you can see a ketone where you have got both the sides ethyl and in between ketone. So can I call it's a benzaldehyde plus pentane 3-one. So I think so the correct answer is benzaldehyde with pentane 3-one. I think so the correct answer is D. Is it done? Let's proceed with the next part, kids. What we have on the next screen. Now here they have given identify the compound X in the following sequence of the reaction. Now I think so child, this is one of the very common reaction in chapter aldehyde. Side chain chlorination followed by hydrolysis. Now what is the concept over here? Suppose if I have got a toluene unit, correct, it's a toluene unit attached CH3. Now it has been treated with a chlorine in presence of light. Now child, you know that chlorination can take place in 2 ways. One, it can take place on the ring, and second, it can take place on side chain. Now whenever in presence of light or high temperature is given, the reaction takes place on the side chain part. So here your chlorination can take place, and since we are going to carry out reaction over here by taking 2 moles, so here the product obtained would be as CH and there will be 2Cl. This compound is known as benzyl chloride. So here in this case, later on when on hydrolysis in presence or when heating is done at 373 Kelvin, the product obtained is nothing but aromatic aldehyde called as benzaldehyde. So the question what they have asked is the intermediate, and what is my intermediate in this case is nothing but benzyl, which is nothing but, you can check, CHCl2. So this is nothing but your correct answer key. So kids, I think so this is clear. Let's proceed with the next question. Now here you can see the next question on the screen is, what is the IUPAC name of the organic compound formed in the following chemical reaction? Now basically bacha, what has been given over here? It's given Grignard reagent. So I have written a Grignard reagent, point number 1. Now it has been treated with acetone. That's also again very clear. That means it's a ketone. Yes. So basically just do one thing. I'll write instead of this a ketone first. So basically when a ketone reacts with a Grignard reagent, the product is very clear. It has to be a tertiary alcohol. Point number 1. Correct? Now let's take our example. I have got over here an acetone. Correct? And it has been treated with which Grignard reagent? Ethyl magnesium bromide, and further they have got other treatment, which is nothing but first step you have got along with that dry ether, and the second step is hydrolysis. Now the question is what? Point number 1. When a ketone has been treated with Grignard, I think so you get a tertiary alcohol. Point number 1. Point number 2. Point number 2. How many carbon atoms are there in acetone, child? It's 3 carbon atoms. How many carbon atoms are there in Grignard? It's 2 carbon atoms. That means when you do an addition, obviously you are going to get a tertiary alcohol with 5 carbon atom. And let's see what you have got over here. Now if you see 5 carbon atom tertiary alcohol, now when you see this example, it's 2-ol. Now when you talk about 2-ol, how do you write a 2-ol? I think so this is nothing but what you have got is 2-ol. In this case, what is pentane 3-ol? I think so it's something like this where you can see 3-ol. That means both these examples what you can see are nothing but, I think so, secondary alcohols only. Now when you come over here, you can see this is a tertiary alcohol, but the number of carbon atom is 4. Whereas this is also a tertiary alcohol, but the number of carbon atom is 5. So tell me one thing, if you check the product obtained should be of 5 carbon atom, that means your correct answer has to be 2-methyl butane 2-ol. That means your correct answer is A. Is it clear, child? So can we proceed with the next question? Okay. I think so we have got a next question over here, child, which you can see very clearly. I think so we have got over here sodium borohydride. Now child, we know that sodium borohydride can reduce your aldehyde ketone group but cannot reduce ester. So this is that ester group which will remain unaffected, which will not get changed. But your ketone group will get converted to an alcohol. So if you see, over here see, ester group is remain as it is same. Whereas in this case it has been modified. In this case it is modified. In this case it is modified. So very clearly it indicates that your correct answer has to be A. And not only this, your sodium borohydride converts your ketone to a secondary alcohol. So the correct answer key for our option for this MCQ is option A. I hope this is clear. Let's proceed with the next question, child. Now here, child, what is given to you? I have got one compound given to you, and you can see zinc amalgam plus concentrated HCl. I think so. We know this reaction is known as Clemmensen reduction. Now when you talk about Clemmensen reduction, what all information do you have with you? Clemmensen reduction is one where your carbonyl group gets converted to methylene group. This is nothing but what is Clemmensen reduction. Now here if you see, here also there is a carbonyl group, and here also there is a carbonyl group. So both the groups have to be changed to CH2 group. So as per our example, the answer what you will get is nothing but option C. Is it clear, child? Confirm. Let's proceed with the next question. Now, the next question what you have got on the screen is, it's like a match the column. You have got several lists given 1 and list 2. This is nothing but a product formed and this is nothing but a reaction. Now, first of all, only the C. Cyanohydrine is a product obtained. Now, generally when do you get cyanohydrine? When your aldehyde ketone reacts with HCl, because cyano indicates somewhere cyanide group. So, your A is nothing but obtained product when you have HCl. Now, A should have fourth option. Now, A having fourth option is not possible. A is the first, not fourth one. A is not the fourth one. Your A is fourth, so your correct answer is D. And even you can check the other options also properly. Yes? Confirm. So, this question is clear. Let's proceed with the next question. Now, here child, we have got one question. Correct order of strength of an carboxylic acid. Now, basically when you talk about acidic strength, I think so over here, everywhere we have got a carboxylic group, correct? Now, over here in the second example, you have got a functional group which shows minus I effect. In the third example also you have got a functional group which shows minus I effect. And in this case, child, we don't have any functional group which shows plus I effect. Now, as you all know that, child, which group increases the acidic strength? I think so we have discussed even in the batch also as well as here also, that we have got two types of groups. One is electron donating withdrawing group, other one is electron donating group. Now, which group is the one which increases the acidic strength? The answer is electron withdrawing group increases the acidic strength and donating group decreases. Now, basically which group comes under withdrawing? The one which shows negative effect, minus I, minus H and minus R. Whereas which are the donating groups? The groups which have positive effects like plus I, plus H and plus R. So, now if you see, these two groups will try to increase the acidic strength and this will be one who will decrease the acidic strength. So, if anyone asks by what should be the acidic strength order, first and the most important, the least acidic would be the first one. Now, out of second and third, inductive effect is based on distance. So, here it is closer to the acid, so it will have maximum effect and this will have minimum effect because the distance is far. So, as per your distance, your 2 should be more in acidic as compared to 3. So, your correct answer has to be 2, 3, 1. 2, 3 and 1. So, your correct answer is D. Is it done? I hope this is clear, kids. Let's proceed with the next question what we have. Now, see, this is one of the reaction which is given, that ethyl iodide is given. Let's write that. Now, this is ethyl iodide which I have mentioned properly in little open form. Treat this with alcoholic KOH. Now, when you treat this with alcoholic KOH, basically what happens? This is alpha, this is beta. What will happen? This and this particular part will get lost and you will get nothing but the first compound formed is ethene. Now, this becomes your compound W. Now, treat this compound with Br2 and CCl4. Now, basically this reaction is known as bromination, where your addition will take place and your product obtained would be dibromide. So, will I get nothing but over here vicinal dibromide. Now, this is your compound number X. Now, the next case, treat this with KCN. Now, when you treat this with KCN, of course, both the bromides will get replaced by potassium, or it will get replaced, by cyanide. So, here your byproduct will be 2 units of KBr, and what will be the product form? It's nothing but CH2, CH2 having a cyanide unit, this is nothing but your compound Y. Now last step, which on hydrolysis. Now basically, I don't know how many of you remember right now this. Cyanide on hydrolysis gives carboxylic acid. So here your first cyanide also will become acid, and even a second cyanide group also will become an acid, and I think so this is nothing but my final compound called as Z. Now child, if you remember, 4 carbon atom dicarboxylic acid is only known as succinic acid, which is nothing but your dicarboxylic acid. I think so out of this 4 option, the most appropriate option what you can see is option A. So the correct answer for given MCQ is A. Let's proceed to the next question. Now child, over here when you see this question, this is from a chapter Practical Organic Chemistry. Persian blue color obtained during the test of nitrogen by Lissagne's test is due to formation of what? Now child, if you remember, this Lissagne's test is only nothing but called as sodium fusion extract. Yeah, sodium fusion test. Now when you have got sodium fusion extract and it has been treated with ferrous sulfate along with that H2SO4, yes, we get Persian blue color complex. And if you must have seen in the discussion, this Persian blue color is nothing but of complex Fe4 FeCN6 3. This is ferrocyanate, and I think so the correct answer is nothing but option A. Is it clear, child? So your correct answer is A. Let's proceed with the next question. Now the next question given to you is, child, in carrier's tube the compound that is nothing but given ClCH2COOH was heated with fuming nitric acid and silver nitrate. After filtration and washing, the white PPT is formed. This precipitate is of what? Now see, whenever if you have got an organic compound, yes, in a carrier's process or carrier's tube, if it has been heated with nitric acid and silver nitrate, correct, and if white PPT is obtained, it clearly indicates it's nothing but formation of AgCl, because Cl always when reacts with silver it forms AgCl, and that white PPT is nothing but AgCl. I think so in this answer the correct option is AgCl. Is it correct? Let's proceed with the next question, child. The last question. Now here this is one of the example which we have got. If 0.32 grams of an organic compound containing sulfur produces 0.23 grams of barium sulfate, then the percentage of sulfur in it is what? Now wait, the first point is, first of all, what is a basic reaction? Let's take an organic compound. Obviously it should contain sulfur. Now when this compound is treated with nitric acid and sodium peroxide, what will happen? Your sulfur will get oxidized to give you sulfuric acid. Now what we do is, this sulfuric acid is later on treated with barium chloride solution. So what happens? It forms barium sulfate as a white PPT, Now this white PPT of barium sulfate is filtered, washed, purified, and then later on dried. Now what we get from this information? First of all, we know the weight of organic compound is given as W, correct? And its value is nothing but 0.32 grams. Let's consider the weight of barium sulfate, let's say as W1, and the weight is given to us is, let's say, 0.233 grams, correct? Now, how do we calculate this? Now listen over here, child. First of all, you need to find out the molecular mass of barium sulfate, correct? And I think so. You can calculate the molecular mass of a barium sulfate. You have got, see, weight of mass of barium, sulfur and oxygen. Now, after calculating, yes, what do we get? We get the total is 233 as the molecular mass for barium sulfate. Now, what is the calculation? Over here, just see. 233 grams of barium sulfate contains 32 grams of sulfur, correct? Therefore, if we have got in the experiment W1 grams of barium sulfate will contains how much? So, it will be 32 into W1 upon 233. But now the question is asked, what should be the percentage of sulfur, correct? Now, how to calculate percentage, child? Whatever the value is given of the weight, we take that. Yes. Then multiply by 100 and upon the original weight of the organic compound. Now, after substituting the values, what you can see is, let's write what we have. Over here, 32 is as it is. W1, what is W1? It's nothing but 0.233 upon 233 multiply by 100 upon W. What is W? It's 0.32. Now, suppose if you calculate all these things, it comes down to, I think so, it's a very simple calculation. Yes, it comes down to 10% of sulfur what you have got. So, the correct answer for this MCQ is option A. I hope this is clear, child. Fine. Thank you very much, child.